as x goes to 2 if x squared minus 3 equals 1. That makes sense? Well, calculation-wise, it kind of makes sense. Let's prove it. Okay. Again, start by saying, given any epsilon greater than 0, there exists a delta, and write down what delta is. Okay? So that when x is delta units away, that's going to make the function less than epsilon.
Were you giving the zeros less than the absolute value of x minus 2?
Okay, that guarantees that x can't be equal to 2. Okay?
Do you always have to have that?
Yeah, of course.
And the 2 is the limit going to whatever.
X is going to 2.
Okay.
But x can't be equal to 2.
Because you
So,
will get a 0 on the.
Otherwise you get equal 0. We don't
Yeah.
want that. We don't want x to be equal to 2. That's why we put that there. Okay?
Thank you.
Alright, so let's do the plan now. Start from where you want to end up. You want to end up here. The function minus the limit less than epsilon. That's where we're trying to end up. And we want this inequality to look like an expression that contains absolute of x minus 2, right? So that we can, from the right side, get what delta is. Okay? Alright, so this is x squared minus 4 less than epsilon. Again, keep your eye on the target. I have to get x minus 2 somehow. Well, this just factors. Okay? But you will be forced to divide by this so you can get rid of it. Right? But don't do that. Because the delta that you get on the right side only has to depend on epsilon, not x. Okay? So we have to think about the size of x plus 2. Alright. Here's something to think about. Look. Our goal is to find delta. Right? There is no correct delta. There are deltas that work, there are deltas that don't work. Okay? We just have to find one. Okay? The definition says, given any epsilon, there exists a delta. It's going to be one or more. Okay? For simplicity, there's nothing wrong with assuming that delta is less than 1, for example. Less than or equal to 1. Okay? Delta could be less than or equal to 1. Okay? How does that help? Well, the problem with the expression I have here is that I don't know what this is, and I can't divide by it because I don't want x's on this side. I want to replace this by a number. Okay? In fact, to make sure that x minus 2 will be less than epsilon, let me try to figure out what's the worst case scenario for x plus 2. Okay? What's the largest it could be? Well, we don't know. Right? We don't know where x is. So we kind of simplify our work by saying, well, x is within 1 unit of 2. Okay? So x minus 2 less than delta. Let's say we're working with deltas less than or equal to 1. At least we know where x is then. Okay? If delta is less than or equal to 1, right? That's what we know. And that gives us an idea of where x is. Correct? Okay, so we're trying to find out the size of this quantity. The worst case scenario. So in order to make this, we'll just add 4 on both sides. So we get 3 less than or equal to x plus 2 less than or equal to 5. Does that make sense? So if delta is less than 1, then x plus 2 is always positive. So whether you have absolute value or not, you don't really care. Okay. What's the worst case scenario for x plus 2? What's the largest it could be?
1.
X plus 2 is at most? And you don't read my handwriting? This is 5. You get 7 for it. I'm not saying where x is, I'm saying x plus 2 is at most 5, right? That's the worst case scenario. And we want this to work even in that worst case scenario, right? So just put right? Less than epsilon. Because if we say that delta is less than or equal to 1, right? We can pick any delta that works, right? And to simplify our process, let's say delta is less than or equal to 1, right? Then that tells us that x is within 1 unit of 2, right? So x is between x minus 2 is between -1 and 1. That tells us that x plus 2 is between 3 and 5. When you're trying to make something small, right, and you want to guarantee that it's small, you assume that everything goes wrong, but you still want to win, right? Okay. If everything goes wrong, the worst thing that can happen is that this is 5. Can't be more than 5, because we just saw why. So you want this to be less than epsilon, even in that worst case scenario. So just put 5 here and make it work. Yeah?
I was told in my last class that you want to pick the smallest value for delta.
Uh-huh.
Is that correct?
That's not necessarily true. You don't need the smallest value for delta. You need a delta that works.
Okay. So it's like you could be like more on one side than on the other side. The function's not a...
Well, it should be the smaller of the two.
Right. Yeah.
Because then it might get away from the interval.
Right.
And that on one side it may not work. So you take the more restricted delta. The question was, let me show you in the picture, this is important. If this is 1 and we turn out to make x between, let's say, 0 and 6, if that interval works, right? Remember, you want delta this way and delta this way. It has to be equidistant from the point that you're interested in. This way is 1 unit, this way is 5 units. So to guarantee that you're still good, you always take an equal delta, the smaller of the two. Because if you take the 5,
Or ensuring that, basically?
yeah, we will take care of that right now. But yeah, if I take 5, then this will get out of here and it won't be good. We'll take care of that, yeah.
Instead of 4, would we be adding 2 to both sides?
We're trying to look for the size of x plus 2.
Right.
So how do you make x minus 2 into x plus 2?
Oh, right.
Okay. So absolute x minus 2 has to be less than epsilon over 5. Right? So here's a candidate for delta. Right? This is a candidate for delta. Why do I say it's not delta, it's a candidate for delta? Because this only works under the assumption that delta is not more than 1, right? So to guarantee that I get the good delta, I have to make sure that it's equal to this and that you're less than 1. Yes? So your delta will be the smaller number of 1 or epsilon over 5. Minimum of 1 comma epsilon over 5. Smaller of the two. Because if delta is smaller than 1 or smaller than epsilon over 5 simultaneously, then this process is satisfied, right? And this replacement is satisfied because I'm guaranteeing delta to be less than or equal to 1.
Why you choose delta to be less than equal 1?
Okay. Since we're trying to isolate this on one side of the inequality, we have to get rid of this x plus 2, right? Okay. Well, we can't divide by x plus 2 because on the right side, you only depend on epsilon, not x. Okay? So we have to have an idea of how large x plus 2 is. That depends on where x is, right? How do we control where x is? How do we control where x is? Delta. So we have to start making an assumption about delta. You could say delta less than or equal to 2. Delta less than or equal to 3. But you have to say something in order to get some control over x plus 2. Okay? So that you can replace it with a worst case scenario that is a number. Okay, so you can isolate this.
So basically you can choose that delta to be less than equal to.
Right. Okay. Well, let's see if this is going to work. Now, we did all this garbage, but let's see what's going to happen here. F of x minus 1, well, let's write what f of x is here too. It's x squared minus 3. F of x minus L. Let's simplify that. That equals this. Right? So far, so good? Okay, now we're going to get an inequality. Look. X minus 2 is less than delta, right? So, let's say delta is smaller than these two, right? It's a smaller one, right? So it's both smaller than this and smaller than this. So, in particular, x minus 2 is definitely smaller than epsilon over 5, right? And according to that, if delta is less than or equal to 1, then x plus 2 is less than or equal to 5. And we're guaranteeing that delta is less than or equal to 1 because we said it's either 1 or smaller than 1, right? Okay. That means this is less than 5. This times this is epsilon. And there's your conclusion. So you said this implies f minus L is less than epsilon, which is where we wanted to go.